Hello again, it's time to do some random encounters in Godot 4. We're going to implement Final Fantasy VI's random encounter system exactly as it is in the Super Nintendo version, and we're going to do it in Godot 4 here, continuing from the last tutorial. So I'm using this site as a basis. I'll put that link in the description. Here is the algorithm for the random encounters. Essentially, it's adding a number such as 192 to a counter, and then that feeds into the algorithm. That does change depending on if you're in a town, but this is going to all be evident in the code. So here I've made an encounter controller C# script, and to start off with, this is going to get auto-loaded. So right here, if you're not already familiar with that, then auto-load. Here you put any scripts that you want. It'll create a singleton of that script. You can also create a static class, and you don't have to add it there, but in this case we're going to use some of the properties in the node, so we can't do that way. So here we have is walking. We can set that to true or false, and that'll determine if we're going to increment this counter. This counter increment, like I was saying, if it were in a town, you could change this to 112 wherever. This counter is actually going to be used to store every additional increment of this number. So, every time we're going to add that, and it's going to store that cumulative number in here, and that's going to be factoring into the algorithm. Random number generator is part of that algorithm, so this is just C#'s random script, and that's how we're going to generate our random numbers. This is just going to store the random number, and the seconds counter is going to store, obviously, how many seconds have passed right down here. So basically, in the original game, every time you took a step, that was a factor into this increment. So in this case, every frame is not going to be equivalent to a step. So in my previous tutorial on animating good old Locke in there, we talked about how the animation on him was going to be I should specify I put him into his own scene here to clear this up. So when we do his animations, one of his walk animations, if we look here, every frame of animation is 0.2 seconds. That worked out to look pretty similar to the Super Nintendo. So what I'm going to do here is every 0.2 seconds, we're going to increment that counter instead of every step, because that's going to work out to every step. So what we're going to do is trigger the code that increments the counter every 0.2 seconds, which is going to essentially be every step, because that's what separates these frames of animation. So here, if they're walking, so something I forgot to mention here is this is walking variable. So this is going to get set from the character controller. It's a small update that was made from the previous version of the script, and it's right here and here. It's based on the input, so if they're not pressing anything, just like we controlled the animation here, we're going to set this variable to false, or if they're pressing one of the directional buttons, then we're going to set it to true here. So that encounter controller.isWalking, that's going to set the variable in this script right here. So it's declared here, and it's a static variable, so that's why we can access it from here, even though the encounter controller is instanceable. And the seconds counter is greater than or equal to 0.2, which is again our frame essentially. Then we're going to increment that battle counter essentially, and that's all this section right here is doing. We're going to say counter, add the counter increment, so this being 192, we're going to add that onto here, and then we're going to have a random number generated. The random number as specified right here is going to be between 0 and 255. I checked C# documentation, and this does not include the last number, so that's why I put 256 here. So basically, if this random number that's generated is less than the counter divided by 256, so 192 however many times per step divided by 256, then that's what triggers a fight. So this in battle is just a variable. I created this globals script as well, just to keep track of a few variables that we want to be able to access from other scripts. This one is a static class, so you don't have to include that in the auto load for the project settings, because if it's a static class in C#, it's going to be there because there's no instancing of that. It's just there. And I want that in this case because we're never going to need more than one instance of the variables that I'm putting in here. So when a battle gets triggered, we're going to change this to true, and then this isn't going to fire off and make sure we don't repeat, and plus it'll be good to track that. So, and that is done right here. It sets that variable. It resets the counter to 0. And before I touch on this, we're going to get into Godot itself, and we're going to take a look at that. So one thing I want to clarify here is I'm not using tile maps. A couple of reasons for that, even though tile maps are a traditional way to do that. The idea here is to try and replicate Final Fantasy VI's battle system, and doing a full tile map tutorial is going to sidetrack this a lot. And another reason is I think this is a good opportunity to show an alternative way to do that. So this workflow might be if you're more on the artist side and you can make a nice looking world like this, but you don't want to break it up into tiles and have that headache. So what we're going to do is create basically polygons. There'll be two kind of groups of polygons that we're going to need here. One is colliders. I'm not going to go crazy with that just because I just want to be able to demonstrate that. So here we're going to add a child. It's going to be a static body 2D if you want it to be a collider object on the map, and it's going to be an area 2D if you want it to be a battle area. I'll explain that a little later. So static body 2D, I'm just going to make this a little more clear. So I'm going to call this collision, just so we are reminded that it's a collision polygon and not something used to define a battle area. I'm just going to call it Marsh Mountain 1. And I'll just put a collider around here to just act as a boundary. So what I'm going to look here is going to put a collision polygon 2D. And the way you create these is pretty straightforward. All you're going to have to do is start clicking. And there we go. So you see me getting lazy throughout that, mainly because it's just for a demonstration purpose. Another thing to keep in mind is, of course, if you were doing this for real and your character was never going to bounce into any of this stuff or encounter over here, which is mostly the case here, probably not exclusively, then you could consider just throwing some much more coarse lines down here, because polygons, if you get too crazy, probably going to impact performance. But here's essentially the idea. So now this is going to act as a collision mesh. We'll give that a try. So yeah, see, so now I can't go past any of this. Great. Okay, so now this is not really part of the battle system. I just wanted to show, like, here you can add a collider where you want to. And now we also need to have areas where we determine, if Locke here runs into a battle here versus down here, we need to have a way to control how he's going to go into a plains battle versus a forest battle. So this is just going to get in our way for the most part, so we can hide it, but at the same time, whoops, not that, could hide it here. We'll do that later, but right now I'm kind of going to go just around the edges there to define a battle area, so that's going to be next. So again, all this is a child of the gigantic sprite that I have here. And I'm just going to add another one. And this time it's going to be an area 2D. And this is nice because this has the functionality to detect bodies that are inside it. So let's add a collision shape 2D to this. Collision polygon rather, excuse me. And let's do the forest because that's pretty straightforward. All right, and that's going to be renamed. This naming is going to come into play later, and we're going to use this. So I'm going to just name it Battle Area Marsh Forest 1. And I'm just prefixing these with Battle Area versus Collision so it's clear which is which. So one thing we got to be careful of here is now let's say we want to do the plains here. So if we look at this shape, we can see that if we just try and trace around this, and let's say here, for example, we're going to enclose that. So one thing we got to do is be careful to not include the forest inside the plains area 2D. So first we need to add a planes area 2D. I'm going to rename that now as well. Oops. And that's also going to need a collision polygon 2D. So put your Euclid hat on here. And the easiest way I think to avoid enclosing this is to start with it. So I'm going to kind of cheat here and not quite connect this. So that way I can do like so, and then I'll be able to come around and enclose it. And one thing to keep in mind here, I'm probably being more precise than I need to be, especially over here, because again, it's just a battle area, so who cares if it's into the mountain. I don't think it'll cause any problems if we overlap with the static body colliders. But I didn't actually try it, so maybe I'll get proven wrong here. And here, this is where we're going to close this off. And here's where we started from. So, and idea being the collider unlock that we're going to use should be bigger than this gap, so we shouldn't have to worry about that not happening. So now we have this defined as the planes area. So now we don't need to trace around it. We can get rid of some of this mess, or hide it, I should say. And here we can toggle as we need to. So there's the forest area, and here is the plains area. So the naming here, this is where this is going to get used. So keep these names in mind here. The battle area, Narsh Forest one and Narsh Plains one. That's going to be what we're using in here. So one other thing we need to do is I want to put the battle areas that are going to be defining what type of battle scene they get put into a group. And that way we can check for any of these battle areas on the map, and any of them that are overlapping lock are, that's going to be, there's only going to be one, hopefully, and that's going to be the battle to go into. So we're going to name this encounter areas, and same for the planes. So, and this is where this comes into play here. This is why I'm coming back here. So up here we've done all the counter stuff. We've started a battle if we've gotten into this block here. So this is going to get all the nodes in group encounter areas. That's the one I just created. So it'll return everything. You could have 10 of these. It's going to return all of the area nodes on there. And then we're going to iterate over those in this loop here. So this being the key point here, we're going to get the overlapping bodies, which is just this get overlapping bodies function, which is on an area 2D. You do have to cast it like this so C# knows what you're talking about. So this area, the one you're currently looping on, just cast it as area 2D, and then IntelliSense should give you get overlapping bodies. That's going to return an array of all of the overlapping bodies in this particular area. So pretend Locke's standing in the forest right now. What's going to happen is if this area right here is the Narsh Forest, but Locke's not standing there, what's going to happen is you're not going to get anything back here. You're going to get an empty array. But then when it goes to the next area here, it's going to be on the Narsh Plains, for example, and if as long as Locke is standing there, this is going to return Locke, and it's going to return it because we have this. So one thing to clarify is I added a little modification to Locke here. So this is the original collider. It could be up here, whatever. I just don't think we need it there. The problem with this is it's too big. So this is the collider that makes him bump into things like the mountain. But if we use this as a collider to determine the battle area, the obvious problem then becomes where those boundaries were close together over here, that you're going to have the possibility of going over two. Now we can just take the first one, and I do that anyway just as a precaution, but this is large enough where you'd conceivably notice. It would be kind of obvious, like, hey, I was half on the other area. So to get around that, I've added as a child just another character body 2D, because that'll get picked up by the get colliding bodies. And I just call this encounter body 2D so we remember that's what it's there for. And then it also has a collision shape. So we'll hide this one. You see this collision shape is right down here by his feet. So this is going to be what determines what battle area he's in. So the next question that I'm sure is popping into your head by now is how is this going to only overlap the little collider but not the big collider? So this is where we're going to talk about some layers. So if we go down here to 2D physics. So what I've done here is everything by default is using layer 1, but it's not, none of them are named by default. I just went ahead and labeled the first layer default because I don't want to change everything that I've done in physics so far. I only want to specify this. So this layer 2 is going to be called encounters so that we're only going to look for that. So if we go back over here and take a look at these, so each battle area here, if we go over to collision, so what we're going to do, should now be obvious, is we're going to set these areas that determine the battle area to layer 2 only. And then for good old lock, which I believe I've done this for already. So lock, the main character body, is going to be on layer 1, the default one, so all that collision with the mountains works. And this, the encounter body, is on layer 2. So that means this is going to interact with those areas. So if you wanted to get fancier with this, you could loop and do some logic, but since for these purposes the only overlap is going to be the one we just specified, I'm just checking if the count's greater than 0. Careful that if you do want to do a null check on this, this returns an empty array, not a null, even if there's nothing. So do be careful because a null check will crash everything if we try that here. That said, we're going to set the battle area that we pass to the name of that area. So this is the area.name. That's going to return. It'll return the name of the area here. So we're going to have Battle Arena and Arch Forest 1, blah, 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 blah. So the reason we're declaring battle area up here is because we're going to use it outside this for each loop. So if we declare it inside the loop, then we're only going to have access to it inside the loop, and I don't want that. So it's just going to set that when it hits that. And you know what? I should probably break the loop there, because once we've done that, there's no sense in having the CPU chug through the rest of these to no end, especially if we end up having a lot of these. So now this is going to call this battle start method right down here and pass in that area name. So here, this is just logging, no big deal. Now this random encounter sound, that's what I did up here. This is just the sound, obviously. All this does is create an audio stream player in code. This adds it to the scene and then set the stream to the audio file. So I just have it here, random encounter. So we're loading that file in. So this is how you do this in C#, the resource loader.load and then the path to the file, and then cast it as an audio stream because you're setting an audio stream here and it won't like that otherwise. So if we come down here, that's what's going to happen first. So we've started the battle. We're going to play the sound. This is this input enabled flag here. This is so when we see the Final Fantasy VI battle start, we see the character freeze, among other things. So if we still allow input while it's doing that funky camera jitter there, you're going to be able to keep moving. So if we want to imitate the original one, then we need to stop input. So what I've done is create this variable here in the globals. That's set to false here, and I've made a small addition to the character controller. Again, this one we looked at last tutorial. And all I've done is add the whole thing. If this global's input enabled is true, then do this input stuff. So that way it won't work at all while we're going into the battle. So this this is for the fade. So a lot of tutorials already show you that you can do a fade in Godot. And the way you can do that, let's go to lock, is you can have a black image. And that's what I've put here. And this is just in, I reorganize this a little bit. So I just got a black image here. And what I did is I made that a child of lock. Reason being is because along with the camera, this image is going to follow him around. That way it's essentially blacking the screen out. So this modulate property, if we just modulate the alpha, that's what we're going to do in code. So we leave it, to 0 here. That's what this is preparing for, essentially. Similar to above, I want to declare the variable here because we're going to set it inside a loop. I don't really need to loop through the characters, but I'm thinking, hey, if you're doing this later and you want multiple characters, if you follow the original Final Fantasy style, you'll just have the lead character, but just to make it flexible. So let's say you had 5 characters on the screen, you do the same thing, you make them invisible. I should mention that's another thing that happens when you hit a battle in Final Fantasy VI. Your character sprite disappears while it's, just those split seconds before you go into the battle. So that's what this does, is it's only going to affect the one. We're going to set the sprite to the character's sprite 2D. So this, as long as you left the default name sprite 2D, which I did, it'll be a child. Let's do it visually as usual. So here, sprite 2D, because I just left it, that's within the character, just get node sprite 2D is going to pick this up, and that'll be effectively what makes him visible. So that gets that sprite, and the black image, similarly, I actually just used the unique name syntax here to get the black. I didn't put that in his scene, but I added that as a child here. So it will get this, and you'll see the percentage symbol here. That's because I went in, this is to revoke it, but you can go down here and assign it if you didn't already. Access his unique name. That percentage means that you've set that. So this is just another way to get the node. So sprite visible equals false. That's going to make him invisible. And it's going to store this black image down here, which we need down here. We're going to use tweens. So we're going to do a tween on 2 objects. One is this black image right here, and the other is the camera. So if you do this, get viewport, get camera 2D, it'll get the main active camera. And since that's the only one in the scene here, it's going to get this one. And again, it's a child of lock just so it follows him around. So here we create the tween for dimming the screen. So get tree, get tween, create tween, excuse me. So parallel just means they'll run together. So here we set the tween property. This is just the image you're going to change an attribute of, the attribute that you're going to change, the value you want it to change to, and how long in seconds you want it to take. So, and this one is actually a little counterintuitive. You can type in the property that you're doing. A thing to remember if you're doing this in C#, by the way, is if you're looking at properties over here in the inspector, and if you hover over, you'll see the underscore in the lowercase. If you're in GDScript, then you'll want to use this, like the underscore lowercase one. In C#, they tend to be renamed with capital letter starting each word and no underscore. So the thing that's a little sucky about that is when you're referring to a property that's going into a function that takes it as a string like this, you have to use the way GDScript would take it. But if you were actually on an object in C#, you would need to type this with the capital or whatever is in C#. So this modulate :A just means the alpha channel of the modulate property, because as you see here, it's 1, 2, 3, 4. And another thing that's not very obvious is even though in the inspector there was 0 to 255, when you change it in the code here, it's 0 to 1. So if you put 250 in here, it's just going to go instantly black. So 0.7 is about where I wanted it, and it's going to take a half a second. And this set delay, you can have it wait for, in this case, 0.1 seconds. And why those values is going to become clear shortly here, if it's not already. So the camera. Again, if you look at Final Fantasy VI go into a battle in slow motion, what it's actually doing is zooming the camera in, out, and then in again. So the simplest way I think to do this is create the tween, and again, set parallel to true is also imperative here because that's what makes this work down here, the chain. So here's the first action we're going to take here is we're going to act on the zoom property of the camera, again, that we got up here. And it's a vector 2 because it's just the x and y zoom factor of the camera. So this will effectively just multiply it by 4. And we're going to take 0.2 seconds to zoom in. Now we're going to do camera tween.chain, which means it's going to, chain it. It's going to come right after this one. And we're going to take it back out to where it was originally, 1, 1. Same thing. And then lastly, just zoom in again. So this is a lambda expression, but basically tween callback is going to let us do an action after that tween's completed in a simple way. Basically, it's going to run this code afterwards. And again, here, set delay just delays it by however much you specify here. The reason I have some delays on here is first just to show the use of it, but secondly, just try and get it as close to the original game as I could, or at least without looking at it as a reference. I just did it by gut feeling. So to come back quickly here, this 0.5 seconds and this 0.1 seconds, that adds up to 0.6. That way it completes the fade at the same time as these complete, because 0.2, 0.4, 0.6, and here this should be 0.6 as well. So this doesn't necessarily need to be a separate method, but more might get added. So all this is Godot's change scene. This is a Godot 4 change, I believe. So change scene to file instead of just change scene, and then scene file. Now the file is just getting passed in this. So this is C# notation. If you put a $ in front of the string and then brackets, you can just fill a variable in there. So it's going to pass in that battle area we were talking about. It's going to pass in this name. So that's why the name is going to become important, because this is going to be the name of the scene that we load. So here we got Narsh Plains and Narsh Forest. I just did a quick lame upscale of both of these just to show the functionality and play the classic battle theme. So it's going to load that. So to use this method, you would just need to make sure you name the scene exactly whatever you named the battle area. Okay, so let's give it a try. Click the right thing here. La, 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 la. Well, that's not good. Let's see here. Can't open a file .tscm. Well, I suppose you can't because it doesn't exist. You know what? I think this something here I'm not thinking of. I bet it was adding this break. Probably stopped on forest areas. Let's try once more. At least we get to see the effect again. There we go. Now pretend you hopped over here and you've got a repo man. Awesome. Let's just try the forest. Ooh, almost didn't make it. Okay, name all the enemies that would be here. Alright, awesome. So there we have it. Final Fantasy VI Random Encounters.